So lately we've been talking about all the different parts of the big picture, this photo that we see here, this diagram. Let's talk about it a little bit more. So the process is you produce data, or someone else maybe produces data, and you use the data to do some kind of statistical study, and then we explore data analysis. So a lot of times you make a chart or a bar graph or a histogram, one of the types that we've seen, just so we can kind of draw some conclusions based on the visuals, and then we'll use that data and all the analysis we've done to calculate some probabilities and then inference will draw conclusions from it and be able to predict the future a little bit, perhaps in different ways, like saying, oh, this new drug, when it went to clinical trials, this new drug, it's found that it'll cure 1 in 4 people from this disease or something like that. With inference, we can use the past data and the analysis we've done to predict the future using probability. So producing data, let's look down here now where we're highlighting how we collect data and what considerations affect the data production process. In Unit 6, we will discuss surveys and experiments and the important role of random selection and random assignment. So remember we talked about random selection, random assignment. We want to make sure that we don't choose people from a certain group or a certain place, or we want it to be as random as we can. Obviously, it won't always be perfectly random, but we do it the best we can so we get a good group of people or objects or things or whatever it is we're using. Exploratory data analysis. These are tools for representing data with graphs and numerical summaries and tools for exploring relationships between two variables. These were discussed back in Units 2 through 4. That was a while back. You might want to look back at your notes, and there should be some there. Now, a lot of times the things that we did in the beginning seem easy now because what we're doing is more complicated. But our eventual goal is inference. We haven't talked about that very much, but it's drawing reliable conclusions about the population based on the sample and based on the analysis we've done. Okay, now let's look down here. Let's suppose we do a good job of selecting an unbiased sample. I mean, that's very hard to do, but let's just assume that's what's going on. Common sense tells us that samples will vary. Unfortunately, when looking at a particular sample, we never know how much it differs from the population. This can affect our confidence in our conclusions. So we need a way to talk about and hopefully quantify our uncertainty. Are we 95% confident? Are we 80% confident? How likely are our sample results? This uncertainty is where probability comes into the picture. If we randomly select a sample from a population, we can use probability to describe the uncertainty. We will learn more about the importance of random selection and random assignment in Unit 5. For now, let's use an example to illustrate the big picture at this point in the course. So we'll look at this example about the death penalty. I know, all these examples are bummers. I don't know why. Sorry, everybody. I'm not trying to bring you down on this random day. Suppose we were interested in estimating the percentage of U.S. adults who favor the death penalty. We choose a random sample of 1,200 U.S. adults and ask their opinion. Either are you in favor of or against the death penalty? We find that 744 of the 1,200, which is 62%, are in favor of the death penalty. Our goal is to make an inference about the entire population of the U.S., of all the adults in the U.S., regarding the death penalty on the basis of the opinions of only 1,200 of them. Can we conclude that 62% of the population favors the death penalty? Another random sample could give a very different result. So we are uncertain. To describe our uncertainty or to quantify it, we use probability to describe the likelihood that our sample is within a desired level of accuracy. For example, probability can answer the question, how likely is it that our sample estimate is no more than 3% from the true percentage of all U.S. adults who are in favor of the death penalty? At this point, we don't know how to do that, so don't get nervous thinking, oh, I don't know how to do that. But it makes sense, if this was your study, you would want to know that. You would want to be very confident saying 62% of U.S. adults favor the death penalty. I mean, it'd be hard to say how certain that is because you only took a sample of 1,200 people of the millions and millions in this country. So we'll learn more about that. That's kind of where we're headed. This is just kind of a preview of what's coming in this module and maybe a future modules as well. In this module, we discuss probability more generally. Then we will develop the probability machinery that, is that right? Machinery? Yeah. that underlies statistical inference. A lot of these terms like inference, they sound scary. Oh, inference, that sounds scary. But it's really just using data and probability to predict the future, I guess, about a population. That's all. Now, if you want, you can write that down. If not, I'm sure we'll see that word again. We'll use it so much in these modules, you'll probably get so tired of it and you'll never forget the definition.